Hi, I'm Mr. Miller, and this is a lesson on graphing sine and cosine functions. So just a bit of a disclaimer here. I'm assuming that you are ready to graph sine and cosine functions if you have already examined the sine ratio for angles 0 up to 2 pi, and you've also looked at the cosine of angles for 0 up to 2 pi, and now it's really just a matter of putting that together in a graph. So if that's the case, then you are ready for this lesson. Now, just a little bit of background information. Since sine and cosine do repeat themselves over an interval which we call the period, we do refer to these two functions as periodic functions. Their amplitudes are going to be, in each case, the difference between the maximum and minimum values on the function. And so we'll see specific examples of that shortly. So what I would recommend for you to do in order to graph sine x and cosine x on negative 2 pi up to 4 pi, as we're going to do here, is first of all label the x and y axes. Make sure that the x-axis goes from negative 2 pi up to 4 pi and negative 1 to 1. So negative 2 pi up to 4 pi, obviously, because that's the interval that was specified, you should do the graphing. And what you'll notice is that I've split pi up into 6 equal parts, and you'll see why that's the case in a minute. As far as the y-axis, the scale, I went from negative 1 to 1 because the minimum value you're going to get for a sine is negative 1, and the maximum value is positive 1, and same thing for cosine. So now let's plot some points. So if you have done some work with angles in standard position and you've done sine of 0, you know that's 0. So 0, 0 is the first point on y equals sine x. Pi over 6 as the next angle, if you take its sine, you get 0.5. Sine of pi over 2 is 1. Sine of 5 pi over 6 is 0.5. And sine of pi is 0. So this is in radians, of course, and that would be equivalent to 180 degrees. And this is the first half of the cycle. The second half of the cycle, if you take the sine of 7 pi over 6, you get negative 0.5. The sine of 3 pi over 2, you get negative 1. The sine of 11 pi over 6, you get negative 0.5. And the sine of 2 pi, you get 0 again. And that completes one cycle. So now we can connect this all together with a nice smooth curve. And what you'll notice beyond that is that you'll be dealing with coterminal angles. So the next spot over, 2 pi plus pi over 6 is the same thing as its coterminal with pi over 6. So we're going to get exactly the same sine ratio, which is 0.5. And it continues on from there. So there's a second cycle of y equals sine x. And likewise, what you're going to find is that if you take all of these and you subtract 2 pi, so 0 take away 2 pi, negative 2 pi, it's coterminal with 0, it's going to have a sine of 0. If I take pi over 6 and I take away 2 pi, then its sine will be 0.5, and so on. So I also have these points, which I can join together in a nice smooth curve. And now I've got 3 complete cycles of sine. So I'm going to label that y equals sine x, and now I'm going to go on to cosine. So again, if you are familiar with the angles from 0 to 360 degrees, or 0 to 2 pi, and the cosines of those angles, then you'll know that cosine of 0 is 1, cosine of pi over 3 is 0.5, cosine of pi over 2 is 0, cosine of 2 pi over 3 is negative 0.5, cosine of pi is negative 1. So now we're up to 180 degrees, and this is half of the cycle, going from the high point to the low point. Now the cosine of 4 pi over 3 is negative 0.5, cosine of 3 pi over 2 is 0, cosine of 5 pi over 3 is 0.5, and cosine of 2 pi is back up to 1. So this completes one cycle of cosine. And now if we add 2 pi to each one of those angles, we'll get coterminal angles, and they will have the same cosine. So I can fill that one in. And if I subtract 2 pi from all those first set of angles that we were looking at and take their cosines, we get exactly the same ratios again. So there we have 3 complete cycles of cosine. So I'm just going to label that y equals cosine x. And now we can go on and answer some other questions about these. So amplitudes of both of these functions, they both have an amplitude of 1. So the amplitude of 1 can be figured out if you go from high point to low point, from positive 1 down to negative 1. That's 2, and half of that is 1. The other way to think about it is this is kind of like a wave, which is created by disturbing calm water. Calm water is like at y equals 0. And how much do we go above that? We go up 1. And how much do we go below that? That's negative 1. So it's the magnitude of that, and the amplitude is 1. Now, both of these functions have the same period, which is 2 pi. And that is the interval that it takes to complete one cycle. So you'll notice that sine going from 0 to 2 pi, that completed one cycle, and then it just repeated itself. Cosine likewise from 0 to 2 pi, that completed one cycle. So there you go. Now, how are the two graphs related? Well, you can tell that they're both exactly the same size and shape, just one is shifted compared to the other. So one way to say it is that y equals sine x is the same as the graph of y equals cosine x, shifted to the right by pi over 2 radians. Now, I mentioned about amplitude that you can figure it out in a few different ways, either going from the high point to the low point, which is 2, and taking half of that, which is 1. The other way you can figure out the amplitude going from the middle and asking how much do you go up from there, 1. I should also mention that period, you can figure out period by starting from the middle and not counting to here, because that's only half a cycle, but asking, from here to there. That completes a full cycle from 0 to 2 pi. The other way to figure out period is to go from high point to high point, horizontally, how far across, or from low point to low point. Or you could go from any other point, so say from here to there, okay? And that would also be an indication of the period. So a few different ways to measure the period, just like there's a few different ways to measure the amplitude. So just finishing up with this last one, when we're talking about doing a shift, if we're shifting cosine to the right pi over 2, that's like replacing x with x minus pi over 2. And what you get as a result is the sine graph. All right, so that completes example number 1. Let's take a look at the next situation. So we're doing some simple transformations here on sine x. So I'm going to label the x and the y axes. I'm going to go from negative 2 pi to 4 pi as I did before, but this time I'm going to go in y from negative 3 up to 3. And the reason for that is because you can see that we've got 3 times the size for sine x. We're also going to take a look at a vertical compression, but the vertical stretch is the one that comes before that. All right, so let's take a look. So we know what y equals sine x looks like. It looks like this. So I'm going to do a couple of cycles. All right, so now I'd like to do 3 sine x. Well, the way that we do 3 sine x is, so you notice that the zeros are invariant. But if I take this y value and I triple it, I go from 0.5 up to 1.5. And this maximum value of y equals 1 goes up to y equals 3. Okay, so tripling all the y values, 1.5, tripling negative 0.5, negative 1.5, tripling negative 1, I get negative 3, tripling negative 0.5, I get negative 1.5, and there's an invariant point. So now I can complete this one cycle. And this is y equals 3 sine x for one cycle. And now I can repeat it on the next interval. And I can also repeat it off to the left there. So now that's a vertical stretch by a factor of 3. And I'm going to label it y equals 3 sine x, just so I don't get it confused with the other ones. And now the next thing I'm going to do is I'm going to look at y equals 0.5 times sine x. So what you'll notice about this one is that it's vertically compressed by a factor of a half. So every y value is halfway in towards the x-axis. So instead of having a maximum value of 1, we've got a maximum value of 0.5 and a minimum value of negative 0.5 instead of down to negative 1. So there is one cycle of y equals 0.5 sine x. And now I can repeat it one more time to the right and one time to the left there. And that is y equals 0.5 sine x. All right, the amplitudes. So we know that the amplitude is 1 for y equals sine x. The amplitude is 3 for y equals 3 sine x. And the amplitude is 0.5 for y equals 0.5 sine x. So you determine amplitude by either going from the high point down to the low point. So we already knew the y equals sine x had an amplitude of 1. So for 3 sine x, we go from positive 3 down to negative 3. That's 6 units. And divide that by 2, you get 3. That's the amplitude. Or the other way to think about it is, if you're starting from this middle position, how far do we go up, which is 3, and how far do we go down? It's the same 3. Now the amplitude of 0.5 sine x, obviously same kind of idea. So maximum value 0.5, minimum value negative 0.5. So if you take the span of this vertically, which is 1, and divide it by 2, you get 0.5. So you also notice that the amplitude matches the coefficient in front of the function, right? The amplitude is 3. Yeah. Okay, as far as the period is unaltered by a vertical stretch, so they all have a period of 2 pi. So now let's take a look at the graph of y equals cosine x, cosine 2x, and cosine x over 3. And so my axes, I'm going to have it go from 0 up to 6 pi for x, and y is going from negative 1 to 1. So what you'll notice this time is that we've got our usual y equals cosine x, and now just doing a few cycles of that. The third cycle. And so I'm going to label that y equals cosine x. If I want to do cosine 2x, this is replacing the x with a 2x, and so it's horizontally compressed by a factor of a half. So I complete one cycle in half the interval that I completed a cycle for cosine x. And so it's done one cycle by pi instead of 2 pi. And you'll notice every single point, so this is an invariant point because it's on the y-axis, but if I go half of this x value takes me to here. This x value was at pi over 3, so now this is at pi over 6. This was at pi over 2, so now it's pi over 4. This point was 2 pi over 3, so now it's at pi over 3. And this point here was at pi, so now it's at pi over 2. So every point is compressed horizontally by a factor of a half in towards the y-axis. So you can complete one cycle in that short span. And now you can repeat it. And so you've got several cycles of this graph in that span from 0 to 6 pi. So I'm going to label that y equals cosine 2x. And then the last one, I'm replacing the original cosine x with cosine x over 3. So this is horizontally stretched by a factor of 3. And so you'll see that this takes, all the way up to 6 pi just to complete one cycle. So 2 pi, 0 to 2 pi, normally to complete one cycle. Now with this one, it goes all the way out to 6 pi to complete one cycle. So it's horizontally stretched by a factor of 3. That is y equals cosine of x over 3. So amplitude of all three is the same. They have an amplitude of 1. but the period is different for each one. So for y equals cosine x, we've got a period of 2 pi, or as a joke, you could say the period is the end of a sentence. Ha 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 ha. So seriously though, the period is 2 pi. For y equals cosine 2x, the period is pi, which is 2 pi divided by 2. And for y equals cosine of x over 3, the period is 6 pi, which is 2 pi times 3. So notice how when it's horizontally compressed by a factor of a half, we get half the period. The period is half of what it was. And when we've got a horizontal expansion by a factor of 3, the period is 3 times what it was. So in general, when you have a function a sine bx and y equals a cosine bx, they have an amplitude of the absolute value of a, and the period will be 2 pi divided by the absolute value of b. So now final couple of questions here. Period and amplitude of these the function y equals 1.5 cosine x over 4. So the period is 2 pi divided by 1/4. And so that's like 2 pi times 4, or 8 pi. So this is horizontally expanded by a factor of 4, right? So that should make sense. And as far as the amplitude goes, the amplitude is 1.5. Final question here, we've got an equation. What is the equation of the sine function that passes through 0, 0 with a positive slope at x equals 0, has a period of 4 and an amplitude of 5? So when you're thinking about something that goes through 0, 0 and has a positive slope, you're thinking probably it's y equals sine, right? But the period here is 4. So 2 pi over b has to be 4. And if you cross multiply and divide to solve, right, 1 times 2 pi divided by 4, this is the b value. And so that b value is going to be 2 pi over 4. Or you can reduce it to pi over 2. And the amplitude of 5 is 5, so we put that out in front. So as I mentioned, you can simplify that coefficient of x to just pi over 2. And that completes this last example. So I hope that helps you understand the basics of graphing sine and cosine functions. Thanks for watching. Have a great day.